Hello, I do apologise. It seems that I was on mute during that part, so let's just go back a couple of slides. As you know, today's session is on continuous integration and test-driven development of database schemas using Jenkins and Redgate. Thank you for joining us today. The main presenter is Dominic Del Molino. If you're on Twitter, do follow Dominic. The Twitter handle is up on the screen now. You may have come to one of Dominic's webinars before or seen him at a conference. If you haven't, a little bit about Dominic. He's an Oracle Ace, a member of the Oak Table, and a Vice President of Systems Architecture at Agilect. So Dominic will be going over the main content for today's session. As always, I'm James Mercer. If you're on Twitter, please do also follow me. I'm part of the Oracle Tools team at Redgate Software, and I'm the creator of allthingsoracle.com. And this webinar is brought to you by Redgate. So a couple of things before we start. Everybody will be on mute for the duration of the event. If at any time you can't hear me, hopefully I have got my microphone on and I'll keep it on. But if you can't hear me, please do first check your own audio settings and do let me know, particularly if the sound quality gets bad, using the chat panel or the questions box. There will be a Q&A session at the end of today's webinar, but please do type your questions into the question box in advance, particularly as Dominic covers topics that you want a little bit more explanation on or that you want to ask Dominic questions. So try not to forget about things, just put it in the questions panel. We won't be able to answer those until the end of the session, but please do type them in advance. This session is being recorded. A recording will be put up afterwards. I do try and get these up quite quickly. I will certainly send you an email when it is up anyway. So before we get going with the main presentation, just want to talk a little bit about Redgate. For those of you that come to these sessions regularly, hopefully you have had a chance to check out the Redgate website and find out a little bit more about what we do. If you're new to these sessions and you don't know about Redgate, then here's a very short introduction. So we produce tooling primarily for database developers and DBAs. We also produce some tooling for .NET developers as well. We specialize in Oracle and SQL Server, but we also have a couple of products for MySQL as well. Over 600,000 technology professionals worldwide use Redgate software, including 93% of the Fortune 100 companies. Some logos up on the screen here, the types of companies that use Redgate's tooling regularly. Our philosophy has always been to produce tools that are easy to use and reliable, but solve complex problems and commonly faced by developers and DBAs. On the Oracle side of things, we specialize in tools to help you deliver database updates through development, through testing and into production. Of course, the heart of this story is the source control system as well. So we have a set of tools that make up the deployment suite for Oracle. These enable you to take the complexity out of recording schema changes in your existing source control system. So traditionally it's been quite difficult to put a version of your schema, of your database in your source control system. It's not like files. So we enable you to do this using our software. Other tools that then come into play, Schema Compare for Oracle and Data Compare for Oracle, enable you to deploy those changes from any version in source control, or indeed any version from database to database as well. There's command line interfaces for the products that enable you to automate the continuous integration, and these are the kind of things that Dominic's going to be looking at today. And then other features enable you to compare the schemas and table data and generate update scripts without writing a single line of SQL. If you want to find out more about Redgate's tools, simply go to redgate.com/Oracle. So I think I've spoken enough now, so let's get cracking with the main part of today's session. I'm going to hand over to Dominic, who's going to go through continuous integration and test-driven development of database schemas using Jenkins and Redgate. Please do bear with me whilst I hand over to Dominic.
Okay, thank you, James. I believe I'm unmuted and showing my screen at this time.
Yep, it all looks good. I can hear you, so I'll leave things with you.
All right, great. And thank you for the opportunity to give this webinar. As you well know from our conversations, this is a topic that's near and dear to my heart. Having been a database developer for many, many years, I've been looking for tools that make my job as rigorous and as high quality as the tools that are available for my counterparts who write, application code. And as you've noted, there are challenges associated with database development. And for my definition of what a database developer does, to me, that's a person who creates tables, creates PL/SQL code, populates reference data tables, basically manages the data infrastructure that's necessary to coincide with application development. I know in many organizations that's performed by a person who wears the title of DBA, but I believe more DBAs are becoming more involved in kind of this iterative agile development process where they're not primarily responsible maybe for operations, but now primarily responsible for ensuring that a development team can proceed at the same pace that they're starting to realize with some of these more continuous integration and agile practices. So I'll talk about some of my experiences there and then explore how you can, for the audience here, how you can potentially use some of Redgate's tools to accomplish many of the same goals that an application developer is able to realize in terms of the feedback they get during their development cycle to ensure their code is of high quality. And that's kind of the goal here, is around this idea of how do we automate tests or create tests that ensure our schemas are being developed in a quality fashion, and how do we do that in a way that can be objective, run repeatedly, proven to someone that we've done what we're supposed to do, and then automate it so we can do it rapidly. So we'll go through some of that as history here in the slide deck. Well, background on myself, as I've mentioned, I call myself a database technologist or database engineer. I've been doing it now for going on it'll be 23 years. I was a former member of Oracle's System Performance Group, the CTO of Savant Corporation, and where I got most of my really good crunchy experience as a director of database engineering at Network Solutions. I like to say that as an Oracle consultant, I got to make recommendations. At Network Solutions, I got to implement my recommendations and live with them. So I learned a lot about that in my time there. I'm currently a member of the Oak Table and Oracle ACE, and as James has mentioned, I'm Vice President of Database Architecture and Engineering at Agilex Technologies. I blog relatively infrequently at Oracle Musings. I also write an official blog for my company, Agilex, on more larger topics, and on Twitter is my Twitter handle. I've written papers on Oracle replication technologies and a chapter in the Expert PL/SQL Practices book from APRS. And I think I'm one of the few people who's both an Exadata certified implementation specialist and a certified Hadoop developer. So I get the opportunity to do kind of big data development and big Oracle implementations as well. And so I wanted to pose what I see as a challenge, and I probably talked about this the most at a UK OUG conference back in, gosh, I think it was 2011, and trying to pivot what's been the traditional model of database development away from this central single-threaded locking kind of model more toward what developers are doing today in terms of having a distributed source code control system. Independent developers can work independently on code and not block each other. And so what we're seeing in the non-database development world is that every developer gets their own environment, and every developer can work independently of the other, and every developer has a copy of the source code repository. They're typically using something like Git, where it's a distributed version control system. And so this idea of a central system that everyone has to go to and wait for it to be updated before they can continue to work is really anathema to the way developers are starting to work in more places that I've been to. And so the traditional database deployment and development process needs some work, right? It uses a central development database. There's locking and overwrite issues, and you can compensate for that by adopting some of these check-in, check-out, and source code locking techniques. But honestly, that's kind of old school now. That's 5-10 years ago. The idea that I have to still coordinate and lock and buy a product that forces me to lock stuff still has this idea of single threading and waiting, which we're trying to get away from. Deployments are usually done with manually created scripts. I think you've probably heard this before. Many of you have heard this before with new tools that can generate stuff and do stuff without handwritten scripts is kind of the way to go as well. You want something that's written the same, it's verifiable, it's consistent. And then also there's this manual review that who checks to make sure that you're following naming standards, who checks to make sure that you're following the character length semantics if you're running a Unicode database and you're not declaring every bar car column as byte and you use car instead of byte. So who enforces that? How do you make sure that those things are followed? And typically I've seen places where that's done with you have to submit to a review process, and it's manual. Again, someone has to come in, log in, look at it, see it, or you have to type it on a piece of paper and hand it to someone to review that your script conforms. And then that's just too slow nowadays. It's just not going to cut it. And so the high levels of coordination, the locking and manual review, they impede progress. And so what happens is your application developers accuse a database team of obstruction. Right? You're not enabling us to move fast. You're working with a manual process that requires centralization, serialization, and locking, and that's not going to cut it for us. So to me, I don't want to argue back. I want to say, no, how can I now get out of my own way and make my process, my database development process, not have to be accused of obstruction? My goal when I was at Network Solutions was to make database development faster than application development, and that was a source of pride when I could say that we're done more quickly than they are, or our deployments take 2 to 3 minutes where theirs took hours. That was a source of pride, and I think that's something a lot of database development shops should strive for, is to not be the reason why an application development effort is slowed down or not occurring at the pace people would like. And so I talked a little bit about this, the evolving methodology for software development in the non-database space, where you have distributed teams, distributed source code repositories. There's no coordination required or no locking of source code, right? The conflicts are kind of expected. They're resolved and merged. You pull code, you resolve merges locally, you push a consistent version of your code. You create a pull request, when you want to get the new versions. And so this idea that multiple teams are working independently and not having to wait for another team to finish something is becoming more and more popular. And even more so now, I'm seeing that every developer has a private full copy of the application that they can make changes to, and that includes the database. So a developer may now have an application server, a database server, and with the advent of cloud and virtualization, it's easier to do that. Right? You can give a developer what I would call a workspace environment that includes a full copy of the database. And I know Kyle Haley from Delphix has done webinars through Redgate as well, and he's talked about this ability to virtualize the database, give every database a developer a copy of the database. So I think you're going to see more of that. The idea that there's one central development database is going away, and developers are each getting their own version of the database that they can make changes to. So there's no single point of failure for development. There's no central thing that they have to wait on. And then also this also adds something, though, that if every developer has their own copy of the database, it emphasizes the need to constantly deploy changes to multiple databases. And so that's different from the model of a central development database where you just go in and make changes to it and then figure out how to deploy it to the one integration database. Now, every time you make a change, you have to figure out how it's going to be deployed, because it's going to be deployed 80 to 100, multiple times. Every time you make a change, it will be deployed to every developer's database. So now you have to emphasize the thought process of, how do I deploy changes? And because I'm going to be doing that much more frequently, much more often to many more databases than I had to do in the past. And so the robustness of your deployment and testing processes has to go up because you have to do it so many times. And that's good, because now you're really testing how to do a database deployment so often that when you do go to production, it's a non-event, because you've been deploying so many times to so many different databases. And so the nice thing about this process is the The software development process is continuous, automatic builds, high levels of feedback, automated testing, automated quality checks, automated security checks, automated compliance checks. The idea is to pull in the QA and security scan requirements into the development process early so that as a developer writes code that doesn't comply or isn't of high quality, they're immediately given feedback and so they can fix it. So you're not having a huge buildup of quality issues or security issues or compliance issues that you then have to deal with later. So how do you pull those into the development cycle in an automated way? And so my question really gets, how can we, now that we understand what the developers do on the application side, how easy is it to change how we do database development? And so the audience I'm trying to reach with this is the database developer who's saying, gosh, I wish I could do my development the same way the application developers do. I wish I had tools that gave me the feedback. I wish I had this ability to rapidly rebuild my database and check it for quality. And so how do I move toward that? How do I leverage the concepts and possibly the tools that are in place that the application developers enjoy? And so I think there are some key issues here, and a big one for me is integration with a source code control system. Placing the artifacts of database development under source code control is a huge benefit, especially if you can leverage existing structures for this or existing tools for this. And this is why I'm a big fan of modeling the database on the file system so I can leverage an existing source code control process like Git, like Subversion, like TFS, so that I don't have to invent a brand new one for databases. Right? There are tools that will do this. You can buy tools that will place schemas in a central schema management repository, but then you're locked into that. And to me, I'd rather take advantage of the file system source code control techniques and technologies which are very mature and have lots of capability to them. So the ability to take a database structure and model it on the file system and place it under source code control is, I think, a big thing, and that's what you can get with things like, I'm going to show you Schema Compare for Oracle and also source code control for Oracle from Redgate. How do we apply changes in a standard automated way? This is the generation of change commands and deployment scripts. This is, again, what we'll see with Schema Compare for Oracle. This is nice, and you get consistency in what's deployed, how it's deployed, and can it be reviewed. And then the last two areas are areas I think that are still, so the first two I feel are almost solved problems. I think if you look at some of the Redgate tools and other vendors' tools, these two issues are solved issues, which is great because 8-10 years ago they were not. But the last two are still areas, I think, of open question and open research. For example, attempting to deploy to a production database, if it fails, you don't have like an easy way to temporarily apply those changes, test those changes, and if they don't work, don't apply them, right? So there's, you can do roll forward, roll back, you can do flashback. There are a variety of ways you could say, change the production schema, and if it doesn't work, roll it back. But I've done work on rollback scripting and writing ways to undo database changes, and it's not fun. It is very difficult and almost as hard to test as the original deployment code. And so that can be a big challenge. And so one of the things I'd like to have is there a way that we can do something just like applications do, where they compile code in kind of a temporary workspace and test it there? They never deploy that code. They bring it up in a testing harness in a temporary spot. So can we do something similar with the databases? And so I don't know of a standard way to do that. I'm going to show you an approach using the Redgate tools to that problem, and invite comments and feedback and your thoughts on that. And then the last bit here too is around data. I think reference data really is like code. It needs to be source maintained, and so what tools exist for that? And I know Redgate has the data compare for Oracle. Not necessarily modeled as script files yet, but then I think that's an area that still needs extra research. But I'm happy to see progress in that area. So I think that's another open question, and I'm looking forward to seeing solutions on. And so, okay, the bit I talked about was, how do I represent the database structure as the file system? Yeah, you can do that with Schema Compare for Oracle. I really think this is revolutionary, or at least something I'm so excited about, in that I can synchronize a database to a scripts directory. And it's not just some proprietary format. It is basically every object gets a file, and it's examinable, it's human readable text. It's not some proprietary format that I have to unbundle and can't manage at the source code control level. and I'll show you what some of that looks like. But this to me is great because now I can leverage that capability. And then if you use source code control for Oracle, you can actively synchronize the database with a particular CM right now with SVN and TFS, and I'm expecting them to add other technologies like Git and Mercurial going forward. The fact that it's a simple structure on disk, though, means it's really easy to use Git even if you're not using source control for Oracle, which is also, to me, very nice. I'm not tied into something. It's flexible. I can use stuff. And I don't think the idea of locking and check-in, check-out semantics are as important as they once were. And that was referencing this DVCS concept, so I like that. And then the other thing, I talked about consistent change application. This is the standardization of deployment scripts. I'm not going to spend a lot of time on this, but I do like the fact that the scripts directory is readable, of scripts of things that look like something that can be deployed. The deployment scripts are consistently built and reviewable. They're very, you can do difference reports. You can generate the deployment script ahead of time and review it. You can keep these things as records so that you can see what was deployed, how they were deployed. You can keep the reports to see, a tracking of that. So now you get a real metrics and measurement around deployment, which you may not have had before, and I like that capability. It's really nice when you're going up for review or auditing of what you've been doing. Okay, so now probably the meat of the thing here is it's not quite TDD, but the question I've got is, how do I run quality checks on database structural changes in an automated way? So, many places will have naming standards, right? Every table has to be pluralized or end with an S, or every table shall not end in an S, or every table must be abbreviated correctly. Here's a standard list of abbreviations, or every column and table must have a comment, or every character column in a Unicode database must use character semantics, not byte semantics, because some characters are larger and take more bytes than others. And so how do you enforce those things, right? You can have someone do review. You can write SQL scripts to look at that stuff. But is there a way that when someone creates a table and we try to do a build of that table and deploy it to somewhere, that we get an error that says this table does not meet our standards? And to me, that would be awesome, because I can then go to a data governance board who has these requirements and say, yeah, we are automatically enforcing your standards with every change we make. And to me, that's, this isn't sexy, but it's something that's really valuable, because having to go through that manually means potential delay, or you have to get a waiver, or an application developer who runs these automated quality checks and security scans on their own code looks down their nose at you. You can't even automatically measure the quality of your code. And so I want to answer that challenge, and so we'll talk about that. I think the key problem here, though, is how do we measure a change before we've made it? And so you could think about ways to maybe build a representation of the database, apply the change to it, and measure it there. But that seems like you need some kind of specialty thing. It'd be much easier if there was a temporary work schema, if you will, where you could apply the changes and then run all your checks against it, and do that before you actually apply the changes to the target production schema. So that's kind of my idea here, is if in a database I have multiple schemas, one of which is my development schema, another one is kind of my temporary place where I attempt to synchronize development to a copy of the production schema, I can do that and then run all my checks on it. So the concept is similar to what the application developers do with the Jenkins workspace, right? This is the space where the build occurs, and I want to model or mimic that in the database. I want a build workspace in the database that allows me to deploy changes and then run checks on it, so I can get feedback on whether or not my changes comply with certain tests. So that's the concept, and I'm going to show you a little bit about how to implement that using the Redgate tools. Talked a little about this. How do we get tested? Can we use a temporary workspace to assemble the code and use database schema? And so the concept I've used is, if you go out on the internet, you can download the Dell Video Store schema, DS2 it's called. But it's a standard kind of performance testing schema that Dell has made available, runs in lots of different databases, but it's a nice one anyone can download and look at. So I wanted to use not some made-up schema of my own, but one you yourself could go try. And it's called DS2. And so one of the things we do in our databases on the development project I'm on is we branch schemas by adding a suffix to the base schema name. So DS2 might be the base schema name, but the production branch might be called DS2 master or DS2 prod, and the development branch of the DS2 schema. It might be called DS2 Dev or DS2 Develop. And so I know when I make deployment changes, I know kind of what schema branch I'm working on. And so what I'd like to introduce is this concept of a build suffix to the main schema, and I call it DS2 build. This is my test schema. This is always rebuilt. It's zeroed out, redeployed using the production schema, and then I use it to test deployments against before I go and test stuff in production. And so here's kind of the flow now. So on the Jenkins server, when a change comes in, the Jenkins server attaches to the integration database. It zeroes out the build schema. Basically, I want to start from a known state every time, so I empty out the build schema. I then synchronize it from the production schema. I essentially copy the production data structures from production into this build schema, so I can use that as a place where I can temporarily apply my dev changes. And I put a question in here. It may even be a good idea to think about when I do that synchronization. Do I also synchronize data, which gives me some ability to test whether or not my deployment has a problem due to the data that's there. And I can set up different data scenarios that I might want to test when I make that build schema. So that's what I like. I have a controlled place that I am running my deployment against that I can set up in a way that is as similar to or as different from production as I like, which is kind of neat. I attempt to do the deployment changes to the build schema. If it fails build, that's great. Then I get feedback that my deployment will work, but I've never messed with production. I haven't messed anything in production. Once I've deployed to the build schema, now I can run any kind of quality and compliance checks I want. I'm going to show you doing that with SQL+, where I run standard kind of select statements, PL SQL blocks, and if there's an error condition where I do not meet a compliance requirement, I raise an error and then the build fails. And so that's the goal here, is to fail a build when I get an error condition and then work on how to fix that. And then if everything passes, then go ahead and deploy to the production schema. So here's the developer side of that. The developer makes changes in the development branch of the schema, and they do that however they like. The SQL developer, PL SQL developer, any tool set Toad, DB Artisan, whatever they're comfortable using to make their changes to the database. And I like this because I'm not asking a database developer to adopt another tool to control how they make changes to the database. They go ahead and make those changes however they like. And then you use Schema Compare for Oracle to, when you're done with your changes, to synchronize what you've done in your local database down to the scripts directory. And once you've done that, then you would run a local build. This is so that you know that when you check in, it's going to succeed at the central Jenkins build spot. So you run a local build where you zero out a build schema, you'd synchronize your copy of the production structures to the build schema, apply, synchronize and apply the dev changes to the build schema, run your checks, and then synchronize the dev to prod locally. So if all that works locally, you know that you're confident that when you check in and push, it's going to work centrally. So if local build succeeds, commit push from the local repo to the origin SCM repo using the DBCS model. So I'll show some of that in the demo coming up, but that's basically the process that a developer uses, and I'll walk through that. I wanted to give an example of what a governance test might look like. And so this is just a simple, we're not going to allow tables that maybe have, maybe you don't want to have, questionable words in your table names. And so here, I don't want any tables with XXX in their name. And so that's a reserved name. I don't want any tables with that string in its name. So if I ever have one of those, I want to report that as an error and fail the build. And so this is a simple thing, right? It's a SQL script that SQL+ can run. It errors out whenever there's an error. It basically selects for the first table that meets that criteria. And if it finds one, it raises an error. If it doesn't find anything, it says there's no errors at all. And when others then raised, so any other potential errors when running this also stop the build, so I have something to investigate. So very simple ability to write a test here. The test is a select statement. It's in the PL SQL block. It raises an error when it finds something. Jenkins will consume this and fail the build, which is what we want. I can now build up an inventory or a library of these kind of structural tests to check for things like the tables have comments and any kind of thing I want, because I have all the power of SQL to investigate the schema. And I like this as well. When I've broached the idea of TDD to my application development counterparts, they've talked to me about using other tools like DBUnit, or we can run this Java test harness. And as a database developer, I immediately get confused. I don't understand those tools. I don't know how to use them. It's a new thing I'd have to learn. What I'm trying to show you here is the average database developer who knows SQL and probably knows it very well can write tests, and that's what I want. I want the person who writes the schema code and writes their own tests, right? So this gets you into the developer themselves writes tests for their code and check in the tests and check in their code. They don't need to rely on another person or another technology that they don't understand very well to test the code that they're building or writing. So that to me, that's a powerful and important aspect of what we're trying to do. So there are benefits to this, right? It's higher quality. Every schema change is automatically validated against the governance and compliance rules. You have a record that you're doing so. So you can go to the governance board and say, your rule is implemented with this test, and it was run this many times on all of these changes in a log. So everything is tracked. Everything is traceable. Every rule is implemented as an objective piece of code. So there's no question as to, well, is it compliant or not, and do we have to get someone's opinion or not? We actually objectify and codify governance rules in code that are always being run. So to me, that's a huge benefit. You're not bound by any particular tools, and you can write any SQL you want for any of these changes, naming conventions, roles being added, security changes, grants being done. Anything you don't like or want to have happen to your tables, you can implement as SQL checks and then have Jenkins fail builds when stuff doesn't comply. So, and to me, this is huge. You can now look an application developer in the eye and say, I am doing quality checks on a constant and continual basis, just like you are. And to me, that's you can kind of hold your head up high and act proud when that happens. All right, so I've done a lot of talking. Let me go and before we get into questions, let me go and show you some of how this gets realized. What I have here, I've swiped screens, and I hope you can see the screen swipe here. This is a virtual machine at Amazon running Windows 2012 server. And so I'm simulating both the application developer workstation or database developer workstation and the Jenkins server in the same place. So I've got a database build job, and I'll show you what that does in a minute. But I'm going to walk through the developer flow. So I've got, whoops, not Twitter up. We'll walk through to SQL Developer. So I'm running SQL Developer 4.0 here. But what I've got on the left-hand side is the DS2 development schema, right? And so this has got a set of tables. This is the standard set of tables that comes with the schema. And so I'm going to do some development. I'm going to add a new table. I'm going to add the product options table. So I've got products, I've got the orders and order lines, but now let's say products kind of options, so an option ID, a description. This database uses byte length semantics, so I did that explicitly, and a price. So we'll go and we'll just add that table. So I'm doing what I would normally do as a database developer, and it's created that table. And so now I have a table in the database, right? So if I refresh here, I've got a new table, but I haven't done anything to make it available to source code control or something that Jenkins can pick up or I can push out. So the way I'm going to do that is I'm going to fire up schema compare for Oracle and synchronize my scripts directory with this with the database change that I've just made. I'll show you how that works as this comes up. So I'll just say we'll start with this. We're going to compare my database to the local scripts folder I've got. The database is DJD, DS2Dev, DS2. Make sure it works, and we're all good there. We'll find where my scripts folder is. And so I've got it in, I actually have it, you can, little check marks here show that I'm using, I've got this under source control. It's actually, I'm using GitHub and Git, and I've got this GitHub database Oracle schemas folder. It's my schemas folder. You can see I've got the DS2 schema in there. We'll talk about this DS2 empty one in a minute. But, so that's my folder, and it's an Oracle 11G scripts folder. So schema compare for Oracle recognizes that. So, okay, so now we'll refresh the list of schemas on both sides. And then we'll say, okay, we're going to do the DS2 dev schema on that side, the DS2 dev schema. That's it. So now what I'm doing is I'm basically extracting my changes from my database and synchronizing it on the disk, on the file system, right? And go ahead and do that compare. So it reads the dependency information, register database. Those of you who've run schema compare for Oracle are probably familiar with this process. Boom, and then it's, you can see it's actually taking a look at some of the files on disk. compare them. It's done with the compare, and now we get to see that there's a change, right? So there's one object that only exists in the database that doesn't exist on the disk. You can see my source code control file system scripts directory. It's this table of product options. Oh, it's okay. We're going to go ahead and deploy that guy to my scripts directory. I'm not going to do any fancy stuff here. We're just going to update the scripts folder. Sure, go ahead and update those two scripts. It's going to add that file, the product options SQL for the table, and update the schema information. Update the scripts. Boom. And so now what I've done is essentially referenced or represented my changes on disk. And so I'm just going to exit out of, I'm not even going to save. Let's do this each time. And so now if I go to like GitHub, so this is my source code control system, right? So I'm using the standard, this is the GitHub user interface for managing source control. And you'll see I've got an uncommitted change, and there it is. It's the table create. And so now I'm going to commit that and say add table product option. Okay, we'll commit that. We'll synchronize it with the master. Okay, so now I've got that change. You know, it's been added to source control. So this is important to me, right? I want this ability to track the changes that are being made. You can see it's at the file level, what object was changed. I really like the script's file structure because it gives me this capability. Okay, so now that I've done that, what does Jenkins do? Now, I am not a Jenkins expert, and actually I want those of you who are database developers not to be afraid of Jenkins. So I didn't do a lot of the advanced stuff with Jenkins. I actually did not hook it up with Git yet because I'm running Jenkins on Windows, and there's some SSH issues with Jenkins and Git that I did not have time to resolve. So what we've got here is simply just going off that file system. So what it'll do in my build is it's actually going to go off the file system as if it had checked it out. So because it's local, I can do that. I'll show you what the build looks like. So the build goes through that build flow I talked about earlier, where it runs a set of Windows batch commands. And so here, I'm running source code or schema compare for Oracle, the command line, the headless version of the GUI I showed earlier. I've got schema compare for Oracle installed on my Jenkins server running Windows, if you like. And so what I've got here is I've got this first bit where it checks to see it empties out the build schema. So I've got a schema called ds2empty, which has got one table in it called myDual, like a dummy table, so that I can basically ensure that my build schema is empty before I start trying my deployment. And if you're looking for some good examples of using this and the error level and some of the other stuff, I highly recommend, I'm going to show this on the other side. There was a really good webinar in June that Michael and Neil had done from Redgate on showing how this works with Jenkins. So they've got some more details there above and beyond what I'm showing here, which is quite nice. Anyway, so I've got that. So I run the first batch command, empties out the build schema, and then I copy the production schema into the build schema. I compare the dev schema into the build schema to deploy it, and then I run my TDD checks. This is my SQL Plus script that checks to see if the table has XXX in its name. I can show you that file here. Right, so this says, you know, whenever there's a table with XXX in its name, you know, assert that that's a reserved name and error out the build. And so we can go here, and you can see it's going to run that, and if it has an issue, it'll fail it. So I happen to know that table doesn't have an XXX, so let's actually change our test, and we're going to say any table with an S in it. So I know I've got a bunch of tables that have S's in them, right? The customers, all of their stuff. So I want to show you that this assertion is run and the build fails. We're going to go and the last thing, of course, it deploys to production. So let's run the build. Build it now. And you can see the build started. We'll go watch the build. We can watch console output of the build. And you can see here, this is the temporary workspace for the build. It's running a batch file that is my commands. The first one here empties out the build schema. So this is empty the build schema. It's copying the production schema into the build schema there. Take a second to So nice, it kind of speeds it up after a while. So now we're actually deploying the development schema change into the build schema. So we're going to see that that table is getting created, it's getting added. You'll see that how many changes are here. It'll find the differences and deploy them. And then you see here it ran my TDD. Here it said SQL plus, run reserve tabling, check, connect. Whoops, assertion failure. That table is not allowed, and that's because it has an S in it. And once it had this assertion failure, the build fails, which is what we wanted, right? And so, okay, well that's not good. So we have to either fix our table names, or in this case, I'm just going to change the test so that go back to the XXX table check. And now if I rerun the build, we'll see that that test succeeds, and I can then deploy to production because that change was accepted. It passed the TDD compliance check. And I have this record in the console output for the job that it ran that test, and you'll see no errors. And that's kind of the assertion model, right? Where the assertion model asserts that a condition is true, and if there are no errors and the condition is in fact true, there's nothing reported. The assertion succeeds. If the assertion fails, then we want to raise an error and report that we have an error. So you could see how we would build up a script that would run your collection of tests and raise errors for the issues that you found and fail to build, which is quite nice. So we'll see the last bit here. It'll pass and then deploy to production. So this is doing this is deploying dev to the build schema. And now it's deploying. You can see here PL SQL procedure successfully completed. That means it passed that ran my script, no errors were raised. It moved on to the next step in the build flow, which is actually deploying development into production. And so once that's done, runs the deployment script, we see success for the build. Nice, right? We get a green build or blue build. And then if I look in my database, I've got another schema, the prod schema. And if I go look there and I look at the tables, I see product options is there. And so that's kind of the meat of it. You can then go and do things like drop the table, check in the change, do the resynchronization, and you'll see that that works as well. But we're coming up on about, I suppose we could do the drop. Let me see if we have time to do the drop. Let's do a drop. So now I'm going to go into, I'm in the dev schema here still. Close that up, and we're going to drop the table. So now it's dropped. So now if we go over here and refresh, we see it's gone. If we go and run schema compare, we will see it removed. We'll see it get recognized that the file's been deleted. So we'll do database to scripts again. Whoops, I don't want inside. Just there. There we go. Refreshing the schema list. And I could save this as a project, and that would probably be convenient. I just wanted to show you how to fill that out when I'm doing that. It's not all that much. Whoops, DS2 dev. Probably ought to save it as a project so I don't have this fingering going on. And so it's going to do this. This is the developer doing it. He's dropped the table, wants to check it in or synchronize it with source. And again, source for Oracle with SVN TFS will do this automatically. I'm actually having to do this kind of manually through this process, but using the source control for Oracle, if you're using Subversion or TFS, you get this capability automatically. You have to go through this. So you can see it doesn't exist anymore. So as we'll go, okay, great, deploy it to the scripts directory. Next, take the scripts, done. And so now, if I go out to Git, let's see. You see the uncommitted change. The red meaning it was deleted, so I've deleted the table. Right, so okay. Drop. Commit. Sync. And then we go to Jenkins, ask for it to build it. And what's going to happen is we should see that it's going to drop it from prod schema. So you still see it here, right, in the prod schema. But as soon as that build succeeds, we'll see that it's gone. And so I guess the thing I really liked about this, I was able to put this together with not a lot of knowledge about Jenkins, not a lot of knowledge about Git, but just using the Redgate tools and my knowledge of SQL and Oracle and database development to do this without any special extra knowledge. Even the tests are SQL statements. So I like this because I think it makes it more accessible and easier for a database developer to use. You could probably even get more advanced with Jenkins doing this. You notice the check succeeded. There's no XXX tables even, so it's good. And then it's deploying it to prod, and then we'll see that it's gone, which is nice. Done. Okay, successful build. We go look in the database, say, okay, cool, refresh, and it's gone. All right, so James, that's all I've got with the demo. I hope that was interesting and useful for some of you to think about. And so I guess we can open it up for any questions if there are any related to the concept or the demo.
Thank you, Dominic. That was really interesting to see, and it was great to kind of go over those points. As you mentioned, particularly as we ran a sort of a session on how to get things set up. So it was really interesting to see it work in action, and also thanks for the tip about the Dell schema, which is something I didn't know about. So we're going to open it up now to the Q&A. There are a couple of questions that have already come in, so please do type some questions in around automating database deployments and using Jenkins and the Redgate tools, and we'll try and answer those now. But we've got a couple of questions to kick off with, so I'll go over those. Okay, so the first question here is, are the tests written first so they fail and then rewritten, or then we write the code to make them pass?
A good question. You could do either way. It's interesting to talk about how something would fail. In this case, you might have to write an existence check, right? Does this table that I'm about to create exist? You could do that. And then your build would fail. You check in your test, the build fails, you check in code, and your code would cause the test to succeed. It depends a little on your standard for green versus red builds. So if you are a place that says you always have green builds, you might write the code and then the test, but you'd always have a test. TDD, of course, is the other way around. You want to have the test checked in, it's a red build, and then you have to check in code to fix a red build. And so it really depends on your standard for green versus red builds. If you're really doing TDD, you would write the test first. You would write a failing test. A failing test in this case is you're checking for a positive capability. So you would say, check to see that this table exists. Check to see if this table has the following columns. Check to see that this table has the following data types. And that would allow you to then, when you're checking the table itself and it gets created, that test would then succeed. So I haven't done a lot of that because it's an awful lot of work that you can just create the table and then write compliance checks to make sure the tables are created correctly. So it's kind of the approach I've taken, but yeah, I'd like to hear alternatives to that as well. James, were there other ones as well, or is that the only question we've gotten so far? So James, you may be on mute if you're trying to ask me another question. I don't see anything coming in, so I can't hear you at the moment.
Sorry, Dominic. I was on mute. I do apologise. So this question is a question I'm going to answer, which is how are GitHub and Schema Compare from Redgate related? So the answer to that question is they're not related in the sense of being products from the same company. If you haven't heard of GitHub, there'll be lots of information on Google. It's a distributed version control system. Dominic may be able to tell you a little bit more about that if you are interested. But what Schema Compare for Oracle enables you to do, as Dominic showed at the beginning, is to create essentially a disk version of your database schema as a set of script files. So I think this is something that is very useful to have a tool to be able to automate that. And what it actually does is, if Dominic drills into one of those folders, will represent your database schema as files with SQL scripts in them. There we go.
Yeah, these are nice because they're like you said, they're basic SQL scripts, and they're easy to look at and whatnot. So I think that's pretty neat that it's done at this granularity, because the source code control system will understand file changes at a file level. Right, so I've got indexes, I've got packages. One of the reasons I like this Dell schema is it does exercise a little bit more than just a simple table. This was great when I was working with the Redgate development on something we can both refer to as a reference schema.
Thanks, Dominic. And of course, I mean, this is where tooling really helps, because trying to create this manually, it just doesn't seem worth investing the time into doing that. Another question here. Could you show where the performance test schema, where you downloaded that from again? I will also provide a link to this in the follow-up email as well.
Oh, you have it.
Yeah, so that might be easier. If you send the link to me, then I'll include it in the email. Okay.
Yeah, I think it's there.
Fantastic. Okay, the next question here. So, Dominic, have you used this and looked at it in terms of how constraints, table space, storage options, and compression options are handled?
I haven't, although I do know Schema Compare for Oracle has the ability to either ignore or check those kinds of things, right? So storage, for example, or table spaces or compression options. I'm a huge fan of my development database, same table space names, same storage options, same compression options that I would use in production. Which means in many cases, I may do auto allocate for a table. I won't create major, large segments ahead of time, or segments ahead of time, because I can't do that in development. But I want everything structural to look exactly the same if I can. So table space names, storage options, compression options, I want them to be the same. So I tend to leave those comparisons on, but I do know Schema Compare for Oracle allows me to ignore those if that's your standard for doing that.
And certainly, if you want to find out more about Schema Compare for Oracle, the best place to go for that is the Redgate website. If you go to redgate.com/Oracle, there's full product details there, and quick link to our documentation as well. So if you want to sort of find out exactly which objects are supported and the types of options that you can use for the tools, best place is redgate.com/Oracle. Next question here is, Dominic, have you tried integrating Oracle's edition-based redefinition into the developer environment and flow that you demonstrated?
Yeah, I have not tried that. It's something I want to do. The biggest challenge I have with it is the lack of branching. There's only a single child, and so I haven't spent a lot of time with it. The other reason it's slightly a challenge is I have to educate my application friends about it in terms of when they log into the database, they have to set the edition they're going to use. And honestly, that sounds simple for those of us who are DBAs, it is, but the Java people, it confuses them. So I haven't tried that. I think that's a place where this idea of temporarily applying a change might come into play. That you deploy to a new edition and test the new edition, but I haven't gone there yet. Definitely an open area for research.
Thanks, Dominic. Okay, a question here again about schema compare. It's quite an interesting one because this is related to how does it handle table data. It's actually a separate tool provided by Redgate called Data Compare. So schema compare for Oracle just handles the schema structure, enables you to compare databases. Dominic showed you to script folders or database to database. Or create snapshots and again do a similar comparison. So there's sorts of kind of three options either side on how you do the comparison and the deployment. If you're interested in comparing table data between environments and updating table data between environments, the tool you need to look at is Data Compare for Oracle. Again, you can find out information about this tool at redgate.com/Oracle. Okay, next question, Dominic. If there are concurrent projects being developed against the same database, how would you differentiate between changes for each project?
So this depends a little on whether they share the same schema or not. Right? It may be that they don't. In that case, you don't have an issue. If they're sharing the same schema, then you have these potentials, right, for merge and conflicts. And the interesting thing is, if those conflicts occur, what will the Jenkins server will expose is a deployment failure in the build. Right? Because the interesting thing is Jenkins is a serialized build. Right? So the changes may come in, but Jenkins is going to do the synchronization only one at a time. So it's essentially and you'll get some of this with Git as well. So for example, what's going to happen, I didn't show this, but when I committed to Git and synchronized with the master, I'm also going to do a poll, so I will see everybody else's changing. I may see conflicts in two tables occur, and then I have to make a decision. Do I accept the incoming change? Do I can find out who did it, of course, where I see it comes from, I have to talk to them. And so you get some of that through Git telling you that there's a conflict, a merge conflict. And this actually encourages frequent small changes, right? So one of the things you want to do is make a change, add a table, commit, send, and go. And so the more frequently you do that, the less likely you are to have conflicts, because if everybody's doing that frequently, then they rapidly see that someone else built a table that they needed, or someone else added the column that they needed. And so this concept of frequent small commits, which is what the application developers do, is something we want to do on the database side as well, so we reduce the probability of these kind of conflicts occurring. And so, like anything, you're going to have potential conflicts. I think the tooling gives you good feedback on when they occur, and then how you handle them is a decision point, right? You have to either talk to the person or find out what the deal is and why they're doing something that's altering your code, if you will. But all of that is revertible through something like a source code control system, and so we do that a lot on our projects. If there's an issue that someone committed something that's wrong, it breaks the build or results in a conflict that breaks the build, then the standard is you better revert your code while we get together and figure out what the heck's going on. So again, green builds, and hopefully these show as issues in deployment, and that's why I like to have this temporary schema, because those deployment issues pop out, and then I get a failed build, I revert the code, I redeploy, everything's green, and we go talk about it.
Thanks, Dominic. So the next question, should Jenkins be installed on every developer's workspace or just on one instance per project stroke team? Or sorry, is one instance per project stroke team enough in your approach?
Oh, thank you. I'm muting me, James. The question was, should Jenkins be installed on every developer's workstation, I believe?
Yeah, absolutely. Or one instance per project team. Is that enough?
We tend to do one per product team, and the reason I showed it here was I was actually using Jenkins to run my build steps. I don't need to do that. I might use a build language like let's say Maven, or more. We use on my project we use Gradle. So Gradle is like a build dependency language, and it can call out this stuff. It could easily orchestrate those sequence of build commands that I was using Jenkins to run. Can be run through a script file that a build interpreter like Gradle would then run. And so in that case, what you would be doing is in your database source code control directory, you would have a build.gradle script, and you would use Gradle to run schema compare for Oracle and your tests locally. And then when you submit your code, when you push your code, the central Jenkins server would run the same Gradle command against its copy of the database to test that your change works. And so you would not need Jenkins on every developer's workstation. You would only need it centrally. And in that case, every developer would be using a build language like Gradle, which, by the way, your Java developers are probably using as well, and your continuous integration support personnel are familiar with. And so, again, I like that. And so you would not need Jenkins on every server. I did this to kind of learn more about it, but you don't need it on everybody's workstation.
Thanks, Dominic. So this is a question regarding the tests. What happens when multiple tests fail? Will it stop at the first error, or will you be able to get a full list of all of the errors so you can work on them all?
Depends on, again, your intent. You could write them to do that. You could gather up errors and then report that if there's any error, you raise something. So the nice thing is you have all the flexibility of PL/SQL to design that. So you could say, I want to record errors in a let's say a PL/SQL array. I want to DBMS output them so I can get a list of them, and then if there's any in that array, raise so that the build fails. So that's one way to do that. Or you might say, no, as soon as any one of them fails, we kick out, and you have to fix your build. It's either approach is fine. The key thing, of course, is that the build fails. And then hopefully there's no list of errors, right? If you're, again, doing small changes, small commits, you start to get a discipline. If they fail on the first one, you're going to get really good at making sure your code doesn't fail any of them quickly. So it's just whatever approach you like. This is why I like the idea of using PL/SQL and SQL for this. Is as a database developer, you can probably design how you want that to work, and you could probably implement it, which means it's under your control, which I really like.
Great, thanks, Dominic. So there are no more questions at the moment. So I think we'll end the Q&A there. Dominic's kindly left his details up on the screen there. So if you do have questions you want to ask Dominic afterwards, please do get in touch. You'll also be receiving an email from me as a follow-up to this session. So again, if you do have any questions, please just reply to that email and I'll get back to you. So thank you everybody for attending the session, and just like to finish off by saying thank you to Dominic again for going through this session. I hope everybody did enjoy it, and do look out for the follow-up email when I send it out. There were quite a few questions about Redgate, so here's the email address again for you to find out more about the Redgate tools that Dominic showed, redgate.com/Oracle. You want to find out more about the company that Dominic works for, you go to agilex.com, and please do follow us on Twitter. Thank you once again, everybody. Thank you again, Dominic.
Thanks, James.
And I hope everybody has a nice day or a nice evening, depending on where you are in the world. Thanks again. Bye now.